I'm Matt Hernandez. I'm a program manager on the Azure platform, and I want to show you how to get your Node.js apps running on Azure. For this demo, we're going to take an existing Mean app and deploy it to Azure using a handful of different tools, including Visual Studio Code, Docker, and the Azure CLI. Let's jump in. Let's start with a project from GitHub, get it running locally, and then deploy it to Azure. This is a to-do app that uses Angular on the front end, Node on the back end. I'm going to use Visual Studio Code to clone this repo, but you could always use your favorite terminal or shell. Open the command palette by hitting Ctrl-Shift-P and type the first few letters of the command we want to run. We'll paste in the repository URL, select the destination directory, and then VS Code will prompt us to open this freshly cloned repository. Now that the project is cloned, we'll need to install our dependencies using npm. I'm going to use Visual Studio Code's integrated terminal for this. Open the terminal by hitting Ctrl-tilde and then run npm install. While npm is running, let me tell you a bit about VS Code and how IntelliSense works. The same way that npm is fetching dependencies, VS Code is fetching TypeScript typings for the project dependencies as well as for the Node.js environment. These typings are what power VS Code's IntelliSense. Alright, npm is done, so let's dig into the code a bit. You can open a specific file in VS Code by hitting Ctrl-P and typing the first few letters of the file name. I'm going to open server.js and make some edits. This app is configured to connect to a local MongoDB instance, but since we want to deploy this code to the cloud, we'll need a way to connect to a remote database. To do this, I'm going to configure Mongoose to attempt to connect using an environment variable, but fall back to the local database configuration. Notice that when I type process, VS Code starts to help me out with the node globals, but this doesn't just work for globals. I notice that there's no error handling for this Mongoose connection, so let's add something basic if an error occurs. Also notice that IntelliSense works for Mongoose the same way it worked for the node globals. Okay, I think we're ready to run this app locally. Let's set a breakpoint, and again, I'm hitting Ctrl-P to select a file and open. In this case, the routes file. Let's break on an API route and run it in Visual Studio Code's debugger. Start the debugger by hitting F5 and notice that Visual Studio Code breaks once we access the app. Here you have access to locals and can step through the code, but let's move on to deploying the app. To deploy this app, I'm going to use Docker. If you haven't used Docker or aren't very familiar with it, don't worry. Microsoft provides an extension in VS Code to make this easy. Click on the Extensions pane, search for Docker, and install the extension. This does require that you have Docker installed as well, so be sure to visit docker.com and click on the Get Docker link to find the right installer for your platform. I already have the Docker extension installed, so let's Dockerize this app. Again, hit Ctrl-Shift-P to open the command palette and type Docker. Since we haven't configured the image for this app, choose Add Docker Files to Workspace. This will walk us through creating the image definition for our app. Choose Node.js and change the port to 8080 since that's the port used by this app. Let's take a look at the Docker file that was just created for us. This image is using the official Node base image, but that image is a little bit larger than I'd prefer, so let's change it up. I do know the image that I want, but notice how VS Code's IntelliSense helps here as well. It's not just in JavaScript files. Also notice that this image defines the start command for our app. In this case, the start command is node server.js. Okay, our image is ready to be built. I'm going to use the Docker extension again to build the image. Hit Ctrl-Shift-P to open the command palette and initiate the build. Select the Docker file that we just created, then give the image a name. I'll prefix the image name with my Docker Hub username for when we push it later. Notice that the Docker extension simply executes the Docker build command in the terminal. You could also do this directly from your shell once you get familiar with the Docker commands. Alright, our image is built, so let's push it to Docker Hub so we can deploy it to Azure. Ctrl-Shift-P and Docker push. For the last part of this demo, I'm going to be using the Azure CLI. This is the newer Python-based CLI that runs cross-platform. When you first get the CLI running, you'll need to log in by running AZ login. But I've already logged in, so let's get into deploying our to-do app. The first step is to create a resource group for our app. You can think of a resource group as a logical grouping of Azure resources. In this case, we'll create a group in WestUS and add a web app and a database within the group. I'm also using the configure command to set this group as my default so I won't have to type it in the next few commands. Next, I'll create the app service plan, which defines the infrastructure that we will be deploying to. I'll include the is_Linux flag when creating the plan so that we get Linux VMs. Now let's create the app service web app. I'm going to create the web app with the I option and provide the custom image that we just built and push the Docker Hub. This command is going to create a new web app in our Linux-based plan, then deploy and run our image from Docker Hub. Remember that the start command is defined as part of the Docker image, so running the image will start the app. Again, I'm going to use the configure command to set this app as my default web app, so I don't need to type the name for the next few commands. Now let's browse to our app and make sure it's running. So there it is. It's running on Azure, but notice the spinner. The page isn't completely loading because we no longer have access to our MongoDB database. Let's provision a Cosmos DB instance with the MongoDB adapter. The MongoDB adapter allows us to use Cosmos DB as a drop-in replacement for Mongo. Let's set it up. Now we have a database, but we need to configure our app to connect to it. To do this, let's add an environment variable that contains the connection string to the database. First, let's copy the connection string. This command may look a bit complicated, so I'll break it down. I'm using some PowerShell features to create a new variable that contains the result of querying the Cosmos DB connection strings. The Azure CLI makes this pretty easy, even though the command looks complicated. What this does is query the connection strings for the database, sets the output format to TSV, then queries the output for a specific connection string value that was returned. Now that we have a connection string, let's add it to an environment variable for our app. All right, so let's refresh the page and check it out. And there you have it. Now when our to-do app starts getting crazy amounts of traffic, we can scale out within the app service plan that we created earlier. Additionally, since we're using Cosmos DB, we can scale our database along with our app. And that's it. We took a mean app, we Dockerized it, and then we got it running on Azure. I'd also like to invite you to try this out for yourself. Visit aka.ms/try-webapps and deploy a Linux-based Node app for free. Thank you.